Alrighty, hey everybody. Um, Hope everything's going well. Today I just wanted to make a short video about the decibel and kind of what that means. I know I'm taking an electronics class, so when it's presented in electronics, it just doesn't feel intuitive because you get this sort of weird formula about decibels being equal to, the log base 10 of the power ratio, which is just like, what the heck is going on there? So I just want to say a few things about that because I found a really helpful explanation in the back of a textbook. It wasn't an electronics textbook, it was a circuit theory textbook, and it had an appendix on the decibel. And so I just wanted to kind of relay that information. The textbook is or Electric Circuits by James Nielsen. Um, and apparently that's the standard textbook that people have been using for quite a long time and blah, blah, blah. Basically, though, this is the gist of it. So the decibel seems to be a dimensionless quantity in the sense that, a unit, a newton is a kilogram meter per second squared, meaning it's 1 kilogram that can go through a meter. Oh my gosh. Okay. Well, it's been a while since I've done this. So I think it's in 1 second, you take a kilogram and move it at a meter per second. And it's the force required to do that, to move a kilogram at a meter per second for a second. I think that's correct. Anyways, but I'm not talking about the Newton today. Anyways, but the decibel isn't really like that. The reason is because it is a quantification of the power loss in transmission lines. So at Bell Telephone Laboratories, which was named after Alexander Graham Bell. So Bell Telephone Laboratories has Bell with two L's. The decibel is also named after Alexander Graham Bell, but it just has one. So what was I going to say? Oh yeah, they were trying to figure out a way to quantify the power loss in these transmission lines or telephone wires, if you want to think of them that way. And so what they did was if we have some circuit or if we have just a flat transmission line, the difference between those two is that transmission lines are more of the actual things. And when I talk about a circuit, at least in theoretical context like this, it's usually a lumped parameter model, which don't worry about that. But yeah, so there's circuits, transmission lines, blah, blah, blah. And we can measure the power at the input of the circuit and the output of the circuit. And we can divide the output by the input. And that is called the gain, or the amplitude of the power signal. So it can either go up, and that's called amplification, or it can go down, and that is called attenuation. And so basically, the reason that we're taking the log base 10 of this power ratio is simply because, let me see if I can remember this. Yeah, so basically our ears do not respond to 1 hertz difference in sounds. So, I mean, if I have, 11 hertz and I go to 12 hertz, your ear is not really going to respond to that. And, excuse me, yeah, so your ear's not really going to respond to that well. But if you have a log base 10 change in the sound, that your ear will detect that. So that's why we do the log base 10. It allows us to measure the differences in decibels, by logarithms. I know if you haven't seen the math, it kind of looks weird, but basically 1 bell is the log base 10 of this power ratio. Now that your ear can detect that, blah blah blah. The other thing I want to say is that it's really weird because, like, let's say I have a gram, and then I have a decigram. So there are 10 decigrams in a gram. If you wanted to get the number, yeah. So usually you would think of, even though a decigram is a tenth of a gram. I know this is probably making no sense right now. That's okay. Basically, what I'm trying to say is, even though you would think you would divide by 10, you wouldn't. because you'd multiply by 10. So if you have 1 gram, you would have 10 decigrams. You would not have a tenth of a decigram. You'd have 10 of them. Okay, so it's the same way for decibels. So if you have 1 bell, you have 10 decibels. And so basically what they do is they say, okay, look, so we have the log base 10 of the power ratio is a bell. So if we want to get the number of decibels, then we need to multiply that by 10. You think, well, wait a second, why not just divide by 10? It's because you're converting to one like bell, and you're trying to get the number of decibels. Um, yeah, and so that's the best way that I know how to explain it. Usually, you wouldn't do it that way, um, at least in my experience. If you have two sides of an equation, and you divide through, and you want to convert, you divide by 10. But in this case, you multiply. So 10 times the log of the power ratio is the correct way to think about that. So sorry, I'm sure this is a little bit boring, but this is just one of my takes, and I might do a few more.